question, just ask in the Q&A tab. I think it's at the top. Okay, so that's the description of the house. That's usually, it's going to be used when you have to do the detailing later on. Okay, so size of all the rafter at 900 centers, fully describe the fixing type. So first you go to the section, so that's the one we need to size. So you go down and you need to find that length. So it's 7.2 divided by 2, so we got 3.6. Just put my calculator so you know. 3.6, and so that's the span. Huh? And then you go to your roof framing table. And the span here. So it needs to be 3.6 and needs to be 900 centers. So you look at here, then you go down until you reach 3.6. So it's going to be this one here, 4.4, and then the size of the rafter is going to be 240 by 70.
You can also use 3.8, which is lower down.
Yep, this one here.
So, yeah.
190. They're both correct. You just need to be more than 3.6.
What did I mention?
Well, for this one, actually, you don't.
You don't need to find out for this one.
Yeah, for that question, you don't need to find out.
Alana's asking about the low dimension. For this structure, remember, you don't need it.
Yep.
But I can explain the low dimension, but it'll be easier when there's a question that you need to find it.
I think later on.
The veranda beam one. The veranda beam one's a good one to explain it off.
Yeah, for now, for just the rafter sizing, you don't need the loaded dimension. You only need to know the spacing and then the span. So the span is 3.6. That's the only thing you need to know. And the question also asks what type of fixing. So if you were to use this one here, the 240 by 70, the fixing is E. And then you go a bit down, and that's the description of the fixing. And if you were to use the 190 by 90, this one, it's a similar fixing, E. Okay, now we go. Size of floor joist and the bearer at 2400 centers. It just means that the distance between each bearer is 24 centers. So you go back to your section. So those here are the bearers. They sit on piles, and if you divide 7200 by 3, you're gonna get 2400. So that's the distance between each bearer. So you go back to your 3604 table, and then you go to floor joist. And because we are inside the house, and so it's dry, so that's the first table. And so we need to be at 2.4 or more. So you can go here. So you can choose this one. 140 by 45 are 400 centers. But you can also use 140 by 45 450 centers, because it's 260. And if you wanted to use 600 centers, mean like the spacing between the floor joists, you need to go for 190 by 45. All those three answers are correct.
Does everyone know how the joists and the bearers and the piles all sit and what it actually looks like? So it's pretty. And then if you know that, then you can easily figure out, or at least visualize the loaded dimension. Because if you don't really know how it looks, it's hard to sort of figure out the loaded dimension without visualizing the shape of it and if it was a real building.
Well, like the bearer, they're running along this way.
Oh yeah, can you make my screen bigger?
Wait, stop.
I'll show you this drawing.
Yeah, but you can use the share
You
screen.
probably see the little one there.
Just use your showcase.
Yeah, hold on a second. One minute, please. Can you see that?
Did you share your screen?
Yeah, it's on my. Yeah, it's a drawing on a piece of paper.
Oh.
Can you see that in my profile picture?
Go back a bit. Yep.
Can you make it bigger? You guys see that full screen now?
Yep.
Mm-hmm.
Yeah, so those members of the piles and the bearers run in the same line as the piles. And then for the joist across here, your loaded dimension, the span is the distance between the two bearers. Does everyone understand that? So the joist, what the joist is sitting on is on those two bearers, but the line of the bearer is also the line of the piles which hold the bearers.
Yeah, should be
Has
good.
everyone got that? Do you understand that? The person who asked that question about the loaded dimension, how that sort of sits?
I think
Sure.
you can't read. But I think we'll just keep on going. And I think there's a question about that. So
Someone asked about it, but yeah.
okay, so now we're gonna go back to question 3. Size of the shortest ridge beam. Go back to our plan. So that's the ridge beam, and if you look on the floor plan, that's this line here. So you get ridge beam here, and you can see that this one is the shortest. So the span of that ridge beam is 3.420. So to size it, you need to know what's the load that is carried by that ridge beam. So the ridge beam carries the rafters, but because this rafter here, the load is shared by the ridge beam and the wall. So the load that he carries is only half of it. So we already calculated before, it was 3.6, the length of that rafter. So you divide that again by 2, it's going to be 1.8. And because it also carried the rafter on that side, so you have to add another 1.8. So total is going to be 3.6. That's the load that the ridge beam is carrying. And now that you know that, you go back to your 3604 fixing roof framing table. Ridge beam for all wind zone. Okay, so now we know that the loaded dimension on that ridge beam is 3.6, so it's going to be somewhere over here. And look at the span, so that's the length of the ridge beam. And we know it's going to be 3.420. So you go down, 2.1, 3.4. Well, you need to be bigger than that, so it's going to be 3.7. and then you go to the left side, and that's gonna. Oh, wait a second. I think you need to go back to your description. The roofing is corrugated steel, so it's considered as light. Because in some other exam, it's like specify concrete roofing, so which is heavy. But in this case, we got corrugated steel. So when you go back to your table, it's okay. It's on the light roof. You need to pay attention to that now. So all the metal one will be on as light, and heavy will be like concrete or concrete tile roof or masonry roof. So it's 3.7, 90 by 70. Everybody got that? Okay. So now we're gonna veranda roof edge beam size and beam to post fixing. So the veranda edge beam, that's this one here. This one that's running along, and it's supported by post. So similar to the ridge beam, you need to calculate the load that is carried by that beam, and you can see it's going to be this rafter, so it's going to be half of that, because the other half is carried by the wall. So the span of that rafter is 3.6. So the load that is half of that, so it's going to be 1.8. So now you go back to your 3604, and still in roofing, and you go to veranda beam for all wind zone. So you can see that there's, so we don't add the thickness of the wall. No, you don't need to worry about that. Because, like you see when they say 7.2, the line for the dimension is including the wall already. Yeah, it's like the other side. Okay, now for the sizing of the veranda beam, so that's the table, and the loaded dimension was 1.8, and the roof, it's still light, it's the steel roof, and it needs to span, the span of the veranda beam, it's only this part here, because it's supported by the post, and the posts are like at half of that, so it's going to be 10 divided by 2. So that distance here is like 3 meters, because after that it's supported by a post, so it's okay. Because if that post there wasn't there, the span will be 5.9. But because there's a post, it's going to be 3 meters. So you go 1.8, go down until you reach 3 meters. So you can use this 240 by 70. And the fixing for that is P. So you go down, P. That's the fixing.
There's a set of drawings on 3604. If anyone else is still confused of what a loaded dimension is, I can, if you go to 3604, in the drawings 1.3, the definitions, it shows a diagram of every member, every type of loaded dimension that you'll get. So
yeah, that's this one.
Yeah, if you keep going down, there's a few that will show the veranda beam in 3D. I'll show you the next one down, yeah. That's there. So that shows you the sort of setup that you'll have, and pretty close to what's in the exam. Same layout.
Yeah, but in the exam we have another post here, so like at the moment the span of that veranda beam is from here to there, but because
that's just between the two supporting posts. It's just, I'll show you where you've got the member span, and then dividing that by 2 for your order dimension.
Yeah, so he was talking about like, yeah, this one here. So divide by 2. So
That's the same for every, so you can apply that same, divide your supporting member by 2 and you'll be able to work it out. But all the drawings for every different structural member are there. So there's your ridge beam one, and
so that's why you take half of each side. Okay, so we go back to we're on the beam table. So it's 1.8, needs to be 3 meters. So it's 240 by 70, and with a fixing of P. Size of the wall stud at 600 center in D1 wall. So that's D1, 3.6 height. So you need to go to the table again. So it's wall, studs, this table here. So you see we got 3.6 for the height, spacing of 600, but then to know your sizing, you need to find out what's the loaded dimension on the wall. So when you go back to your section, the wall here is carrying the rafter, but only half of it because the other half is on the ridge beam. So the loaded dimension for that is 1.8. And in some cases, like in this one, it doesn't have any overhang, so it's just 1.8. But sometimes you maybe have like an overhang of 600, and you'll have to add that 1.8 plus 600 because it's carrying the overhang as well. But in this case, it's just 1.8. So you go here, 3.6, 1.8, and you see here there's like the wind zone. So you need to go back to your description. Extra high wind zone. Table. So it's going to be extra high, 2 meters, the loaded dimension, so it's greater than the 1.8 that we need. And 600 centers, so that's going to be the sizing of the wall stud, 140 by 90. And I think when you write the answer, you write 140 by 90 at 600 centers. At 600 centers. Okay, now size of the door lintel at D1. So that's the door, and that span is 1.8. That's what's said in the description. So for that, it's just like a wall because a door is like an opening, and you need to put the lintel so it acts as a wall, as a support. So you go to your table. I think it's in wall again. Lintel. So that's the table. And it's for all wind zones, so it's okay. And it's a light roof because it's corrugated steel. And the loaded dimension on this one is half again, so it's 1.8. So you can take the 2 meters. And the span is 1.8 as well. So you go to your table. So you can choose this one here, 140 by 70. And well, you could also choose 140 by 90 if you wanted to. They're both okay. It just needs to be more than 1.8. Okay, and so that's it for question 1. Any question for that? If you want to ask a question, it's on the top right, huh? There should be like some icons. You click on it, and there should be a Q&A icon, and then you can just type it stuff there. Okay. Well, there's no question. Let's keep going. So that's. I'm not gonna go over the with the tightness. I think maybe. Yeah. So section B. Calculate the depth, the beam depth.
Are you not going over the
No, maybe later.
construction?
First, I'm just gonna do all the ones regarding the tables. Maybe we can come back to that. Span of 10 meter using a laminated timber beam. So this one is a structure element. So it's this one. So I've already done some of the lines. So it's 10 meter span. You go all.
Pretty's asking for 1.6. Question 1.6.
1.6 again. Okay, let's go back.
For section A, I think.
Size of wall lintel G1. So it's this one here, this one there. So that lintel, it's carrying the rafter. So we know that the loaded dimension on this like wall and lintel, it's going to be half of that rafter. So it's going to be, the rafter span is 3.6. 3.6. Half of that is 1.8. So that's the loaded dimension on that lintel. So you go back to wall. Lintel. So loaded dimension 1.8. So you can take 2. Always go bigger. And then the span was 1.8 as well. So you go until you reach 1.8 or more. So 2 meters. So the lintel size is going to be 140 by 70. Okay. Okay, now let's go back to this one. So for the span of 10 meter, laminated timber beam. So to get the depth, you need to divide the span by the midpoint of that ratio. So in this case, 20. Usually you get the midpoint is like 16, 17, 18, 19, 20, 21, 22, 23, 24, and you take the one in the middle. So that's 20. The loaded dimension is 2 because this you take half is 1.8, and on the table there's no 1.8, so you always take something close but always higher. So on that table it was 2.
Does everybody know what a loaded dimension is? Like what that means?
It's just like the weight that the element is carrying.
Exactly. So the ridge beam's holding half of it, and the wall where the lintel is positioned is holding the other half. And the rafter is the weight on top of the wall and on top of the ridge beam. So half of that weight is being held by the ridge beam, and half of it is being held by the wall. And that lintel is a big hole, making a big hole in the wall so that you've got a door. So that lintel has to be able to distribute the weight of that rafter. And that's what, in this case, the loaded dimension is. So, and then White's 2 is the nearest higher number than 1.8.
Okay. I think we'll just keep going. And if you have some questions, just write them down, and then we can go over it at the end, so we can finish that faster. So as I was saying, like the span is 10 meters, and because it connects here, so you can use that. The timber beam can span that long, and the midpoint is 20. So you do the span 10 divided by the midpoint, so it's 0.5 meters. And because the question asks you to do it in millimeters, so you just multiply by 1,000, so it's going to be 500 millimeters. So that's 500. And second is a cantilever span of 10 meters using a steel beam. So if you read the note below, it said that if it's cantilevered, the span should be double. So instead of using 10 meters, you have to use 20 meters. So you go to 20 meters, you go up, touches, so you can use that. Go here. In this case, the midpoint is similar, so it's 20. So you do 20 divided by 20, it's 1 meter, which is equal to 1,000 millimeters. Then for the third question, span of 8 meters using one-way concrete slab. One-way concrete slab, 5, 6, 7, 8, go up, doesn't touch, so it's out of the scope. You can't use a one-way concrete slab to span 8 meters. Yeah, don't be afraid. Sometimes when you look on the table and you don't find your answer, sometimes it's out of the scope. It's okay, or it needs to be SED, specifically engineer design. So it can happen. Question 4. Which of the following would have the shallowest, means the smallest depth for a span of 10 meters? Concrete one-way slab, rib slab, precast channel, or precast eye? So it's those 4 here. And to know which one's going to be the shallowest, first, what's the span? They asked 10 meters. So I forgot to add that. So you go 10 meters. Okay, you can see that the one-way slab doesn't touch, so it's you don't use that. So you can only use the rib slab, precast channel, and the precast eye. So as a general rule, the shallowest is always going to be the one that has the highest midpoint, because if you divide 10 divided by 22.5, you get 0.444, and if you divide it by 21, it's going to be 47. So of course, like the highest the number here, the lowest the result's going to be. So for that question, the shallowest is going to be the precast eye, because you got 22.5. Awesome. Why is it 10 meters? Well, because that's been asking the question here. What's the shallowest depth of a span of 10 meters? So that's why you get that one. Okay, let's keep going. Using a timber frame, and it needs to span 25 meters, 5 meter high. And for those questions, you always use the structure system table. So it's going to be this one here. Question 1, timber frame. So it's this one here. You go 25 meters, go up. So it reached. So that's like the different legend, like wood, steel, and concrete. So yes, you can use wood. And for this part, you always use the LT, unless they ask you for the height. But for the depth of the frame, it's LT. So you're gonna do 25 divided by 30. That's the midpoint here, like wood. So it's going to be 0.833, which is 833 millimeters. Correct. 25. Yep, the frame. And now for question, the next question is steel spindle frame. So same 25, go up, still here, and the midpoint is 125. Correct your calculator. 25 divided by 125. 0.2 meters, so it's 200 millimeters. Next question. If the height of the frame were 10 meters, could this frame be sized up using these sheets here? So it asks you, can the timber frame or the steel spindle frame can have a height of 10 meters for that span? So for that, you use the LD to get the height. Take your calculator again. 25 divided by 4.5. So it's going to be 5.5 meters for the timber. So can you use timber frame to get a 10 meter height? So it's no, because the maximum is 5.5. Then you check the steel spindle frame. So it's 25 divided by 15, 1.6. So for this one as well, you can't use it. It's too small. Good. Any question about that section? Wouldn't it be one concrete slab? No. Wait. So you were talking about this one. So it's question. This one here. And I did draw this. It wouldn't be the one-way concrete slab, even though it's 30. But then you can't use it because it doesn't span that long. So that's why I didn't put that as my answer. Yeah, for a 10 meter span. Well, of course it would be the shallowest, you got 0, but you can't use that, so. Yep. That's right now. Okay. Cool. Any more question about this section? I was just going to move on to the part C. Okay. I think we can do this part here because I'm pretty sure that's going to be in the test because that's the one he went through during the review. So it tells you to examine the picture and find 6 possible locations where the moisture can get in. So this photo here.
Yo, that's the 2013 paper.
This one?
Yeah. I think you're on the wrong one.
Oh. No, 2014, is it?
No, because the 2014 paper has the what the structural advantages and disadvantages of the Scottish Parliament and the bridges. That's the one in the 13 paper.
Yeah, but I'm not going over this one here because I said that this one has the most of the answer in the lecture. I was just gonna go over
Oh, right. Okay. So
but
you're
if we
going,
have time later on, we can go back. It's just like just in case.
so you're going over the 13 paper for the section C.
Yep. So yeah, that's the 2014. It's just that I've skipped some questions. That's what I put in the description, so
Okay.
we can finish it faster. But we can go over the other question if some more people want it. So for this one, if you look at the photo, water can get in through the windows, and it's usually by wind pressure. So wind blows in and just go inside the windows. Then you have it at the bottom of the cladding, because in this case, like there's no clearance, there's no gap between the ground and the bottom of the cladding, so the cladding can absorb the water. Another one would be like the chimney. For the chimney, you have it on the side, like if the flashing is not done properly, like the metal part that's covering the roof, the water can get inside. You get some roof penetration here. So the water can get in, like most of the roof penetration, the process is by gravity. So if there's a hole, the water will just go in there and drop down.
No, that's the 2014 paper, Robbie. I think it's on page 11 of the 14 paper.
Yep.
Yep.
And then some here, like the junction where the roofs meet the wall. That's same. It's going to be wind pressure. And I think here they were saying there's like a internal gutters. So here you can get some water in if it blocks, like if there's a flood, the water would just get inside the house. Yeah, so that's 6. Well, there's many more, like it can go also at the bottom here if there's no clearance. So with the splash, it can get below the door if it's not separate properly. Okay. The building is reported to have sign of moisture at concrete slab near the red chimney and behind the black wall. Possible cause, well, talked about that already, is like that's the black wall. So usually the moisture on the other side will be because the cladding would have absorbed the moisture from the ground. And yeah, usually it's the same for the chimney. Yep. You okay with that, Ben? I think it's, you have something to add?
I spoke to Max. I said, "Is it going to be the same photo?" And he said, "No." So it won't be this photo, but it'll be all the same. It'll be all the same type of stuff. So yeah,
So
everything that Steve mentioned is it's everything that I can see. Yeah.
So just remember, usually like the windows, the bottom of the cladding, some roof penetration, the roof where it meets the wall, and if there is some internal gutters. Okay, read the sun chart. So the first question, July 19, the sun position and altitude for 9 o'clock, solar noon, as shown on the chart. So July 19, here. So that's this line here, 9 o'clock a.m. So it's this side. So you go here and you make that line. So that's the point. And then you take your ruler. So it's somewhere over that side. So it's going to be like 49. Just make sure it's in line. Huh? So it's 49 degrees east of north. East of north. And to find the altitude, take that point and then you go down. So it's going to be around here. So it's like 14 degrees. Yeah, 14 degrees altitude. Okay, now solar noon. So solar noon is always the one that's on the north line. So this line here. And July 19. So it's going to be here. So the position where it's 0, it's on north. Then to get the altitude, you follow that black line. So it's going to be like 30 degrees something, maybe a bit below. Yeah, it's going to be 32 degrees altitude. And which is like kind of correct because it's like July, June, so it's like nearly winter time, so it's quite low. Yeah, remember, huh? Like June it's lower, summer it's going to be higher. Next one is October 17, the sun position and altitude at 6:30 and at 1 p.m. So October 17, it's going to be that line. 6:30, so 6, 7, take the middle. So it's going to be around this one here. So now it's going to be 94 degrees east of north. And the altitude, just follow down, it's going to be 10 degrees. And the other one is 1 p.m. So same, October 17, 1 p.m. So that's point here. Yeah, somewhere there. So it's going to be like 24 degrees west of north. And then the altitude, it's going to be around 58 degrees. Good. Any question? This one should be easy points. Okay, what's next? Oh, plumbing. Is it plumbing or? Oh, missed the roof. Maybe
Stormwater.
Yeah, stormwater here. So the greatest area of roof serving a single down pipe.
Oh, Dimitri is asking east of north or east of south.
Sure, I thought the solar noon was always on the 0 and then I think that's when it's in some of the exam they ask you what's the position at 12 a.m. 12 New Zealand time.
Yeah, well, like, because I thought like the solar noon was always the true north.
Yeah, I'm just looking that up now because yeah, I'm pretty sure the solar noon tomorrow is at 1:05 p.m.
Or maybe
Go.
is the solar noon like the highest?
Yeah, it's the highest point of the sun during the day. So that's right. That means it's at, if you go up on June 21, it's at somewhere after 12, like 12:30, 12:20. That's
Yeah,
right.
like 12,
It's around
10,
here,
I think.
So it's always
That's right.
on this axis, right?
Yeah, you're right. That's it. If they ask you what time where the sun is at 12 at midday, then you follow up that 12 squiggly line to your date line. But if you want solar noon, doesn't change because they've on this chart the date lines and the timelines move accordingly. So if you've got you're right. I think straight like due north is solar noon always, but it's the days and the times that change around it. So at June 21, it's just after, it was about 12:20, and then if you go to like October 17, it's more like 10 past 12 or something.
Yeah, so that's why it changed. But
Yeah.
like, I think solar noon is just always straight.
Yeah, it's always north in the path.
And if you're looking at the east of north or west of north, always use north as your datum. Don't ever say like south of east or anything like that, because with the degrees always start at north 0. Everything works off that all the way around. So yeah, east of north or west of north.
Just Google solar noon. Eastern cross the meridian is at the highest.
Yeah, the meridian. Tomorrow it's 1:05. So what's that? Would that line up with that chart on November 8th or whatever?
So what, November? So November is also.
Not quite.
But yeah, well, I thought there was like solar noon is like true north, so maybe.
Well, what was the solar noon tomorrow?
1 p.m., 1:05 p.m.
105.
Maybe the chart's wrong.
Said.
Even if you do what they were saying.
This is confusing the shit out of everyone, including myself.
No, because I know some of the question they was asking what's the height at 12 o'clock New Zealand. I don't know which exam.
That makes
That was
sense.
2013, yeah, I think.
That's how you would read it. Yeah. It's just wrong. The chart's wrong. You're right, Steve. The chart's wrong.
Yeah.
Wait,
Next
so
question.
when it says like keeping in mind the local time, does it mean like the time at that point that you're doing the thing, or like what?
What do you say? Keep in mind the local time. What do you say there?
That's in the 13 paper.
Ah, in 13 paper.
Yeah.
Wait, let's go open the 13 paper.
Question 8A, page 10.
Oops. With respect of the New Zealand local time in December, what time is the solar noon on 22 December? That's this chart. So that's the solar noon.
Yeah.
And they say what date? 22 December?
22nd December.
22nd December. So 22nd December here. So that's 12. So the solar noon is going to be like a 12:10, 12:20. Yeah, that's how I would answer that.
Yeah. Yeah.
What time is the solar noon? 12:20.
Okay. Moving on.
Okay. Create a roof area serving a single downpipe. So when you do this, be sure to look at where the arrows are going. So we got downpipe A, C, D, E, F, G. So, like for example, C, the area that's going in this one, it's going to be this. This only, because you can see like the downpipe, the gutter, it's going both ways in the middle. Same here. So that's the surface that's going in this one. And because they ask you what's the greatest, so you kind of have to calculate most of the areas because they look pretty similar, like this one. It's another one. And another would be, oops, this one here. Well, for me, from the look of it, this blue one is going to be the biggest. But if you're not sure, you can just calculate this one and maybe this one. Because those one, like the downpipe D, it's just this area here. E is just this. A, only this. G, only this. So I would calculate maybe this and this. So for that, you need to calculate the surface of everything. So first I'm going to calculate that surface here. So you know that this length is half of the 5 meters, so it's 2.5. And this is half of the 11, so it's 5.5 plus 9 meters, so it's 14.5 times 2.5. So this rectangle is 36. Let me take a paper so I note that. 36.25. Then you need to calculate this one here. So it's going to be half of this. The 7 is 3.5 times 5.5. 3.5 times 5.5. 19.25. And then you get this little rectangle there. So it's going to be 2.5 times 3. 2.5 times 3. But because we just want that triangle, we divide it by 2. So you get 375. Then now you add all the surfaces plus 36.25 plus 19.25. So this one's going to be 59.25.
How do you calculate the area of the triangle again?
The triangle, so you calculate that rectangle here. So 2.5 times half of the 6, so it's 3. 2.5 by 6. So you get that rectangle,
Yep.
and then you divide it by 2.
Oh, okay.
So just to be sure, we're just going to calculate the red one to see that this is the biggest. So we need to have this line. So it's going to be 11 plus 9 plus 6. 11 plus 9 plus 6. Then you divide it by 2. So that's 13. And then you're going to multiply by the 2.5. So it's 32.5. So that's this rectangle there. Then we need to add this one. So that's 12 meter. You take half. That's 6. And then you minus the 2.5 there. So that is 3.5 times half of 11, 5.5. 1925. And so you add the 32.5 that we had before. 51.75. Oops. So you can see that this one is the biggest. If you want it to be sure, and if you have time, you can maybe calculate the other one. But as you can see, those two looks the biggest. This is the biggest. So question 1: the greatest area of roof serving is 25. And you do that because you need to size up the gutter size after, and because you don't want to have different sizes for all the roof plane, so you just take the biggest one and put that everywhere.
Well, what was the greatest size again? The greatest area?
5925.25. So then for the single gutter size, you have to look at the gutter chart, which is this one here. Oops. Oh, wait, maybe I'll just. So we know that the roof pitch is 27 degrees. So when you look at the table, and always look at the external gutter, so that will be the first one. And the catchment that we got is 59, so that's 50, so it's just a little bit over that. Then you trace a line until you reach this line, because 27, so 27, go down, and then you go down here. 5,000, 6,000, 7, 8. So the cross-sectional area for this is going to be 8,000 millimeters square. Yeah. 8,000. Suggest a suitable gutter size. So from the lecture, they always say to assume the cross-section of the gutter is going to be 100. So usually you do 8,000 divided by 100. So you got 80. So the gutter size is usually 100 by 80. Yeah. Good. Okay, now for downpipe size, they allow for the worst downpipe discharge. So the worst is going to be the biggest, so it's still 59.25. So this time you go to this chart. we got a roof of 27 degrees, so it's gonna be here, and we need 59, so 50 too small, 70 it's good, so you go down on the left, 74 millimeter diameter for your downpipes. Yep, so that's 74. And identify the downpipe that take the greatest flow. Well, for me it's gonna be this one. It's gonna be F, because that's the one you receive the most water. Agree? Any comments, Ben?
Nope.
Okay, now let's do the plumbing. So when you first start, look at where the main drain is. The main drain is there. That's the main drain. And in this case, you can see proposed house drain. And remember, you can only have one connection to the main drain, so you can't do stuff like this. Okay, first you need to do the fixtures. So that's the things that you need to look at. I think most people know how to do that. You just look at the table, and then like for the toilet it's going to be 80 by 4. That's usually for all the toilets. And like bath, that's 40 by 4, I think. So you just add that everywhere. Just make sure you check the table. And after that you need to place the floor waste gully. Oops, a bit bigger. So usually you put it in every room, like this one here, one here, and you can connect the bath. Can you explain why
Steve.
By
Yeah, couple of questions.
Okay, first for the 100, if you looked at his lecture, in all his example, he always said, assume that the cross-section of the gutter is 100. When he say cross-section is like the thing that's the depth, the width of the gutter. Because like that's the gutter, and I think that's 100, if I'm correct. So that will be like the 80, or it's the other way. Maybe that's no. I think that's 100, and that will be 80.
Maybe show them like the thing on the lecture.
Okay, lecture.
Yeah, Ruben, you'd be right. If you use rectangular, that's all good.
Okay, sorry for some reason, I don't know why it disappeared, but there. You see, you get the cross-section area. So in our case, it was 8,000. Suggested gutter size. Assume one section is 100 mm, then 8,000 divided by 100 equal 80. So it's going to be 100 by 80.
Is it just there that he's used 100, or has he used it in the other ones as well?
On this one, you use this. Here.
Oh, yeah.
assume one section is 100. I think in most cases it's 100.
Okay.
Now,
Joseph wants to know he wants to see the charts
which charts?
for the plumbing of the house, the sizes, the 80 and the
This one?
yeah, those ones I think.
Yeah, I think you just look like. Here we got. Here you got the legend basin. We just go here. Basin 40 or 30, 32 and 1. So, oh, shit. Excuse me. So basin 42, 40 and 1. Bath shower, it's 40 and 4. See, so that's like laundry. Clothes washing machine, so it's 45. Oh, this one. Is it 44? Yeah, 44. And bath shower, 44 as well. Uh, Sink. $43, or you can use 50 if you want to, but I'm just gonna be consistent and just use 40 because you can. And that's double sink as well. Single or double. Tub laundry. 40. Let's go 5. And WC, it's the water close pan, so it's 84. And dishwashing machine. Let's go back up. 43. Domestic, that's like for residential house. Commercial would be like for shops, shopping centers, stuff like that. So now you get all that. You just place them where they are. So that's laundry, PR, and clothing machine. So it's going to be 4.5, 45, and 40. I think you just need 45 for those two. Yeah, laundry. If you looked at the previous example, the other example, the lecture. Wait. So we had like laundry and this, that's 40 and 5. Sink to do it together, so it's 40 and 3. And it's most like, I've checked in the exam, the arrangement of the room are quite similar everywhere. It's just the shape of the house that change. But usually if those three together, those two, there's always the same arrangement. So just remember those numbers. Go back to here.
Oh, for the shower, you know how you got 40 and 4? There's like, are you using table 6.1 continued or just table 6.1? Because on the other one, the shower single is like 40 and then the unit rating is 2, not 4.
Shower single 42, and you said the other one?
The other one I think was 40 and 3, I think it was.
40 and 4 here.
Yeah.
I think actually that's bath plus shower. Well,
Bath plus shower. I think you just have to use the single shower, or which one do you use?
But look here, that's bath plus those two, like 40.4, so that's for bath, and 40.2 just for the shower. Yeah.
So it's
separate.
Separate. Okay. So you have to use the one that's the 2.
For the shower, like shower single 42.
42, yeah.
Bath with or without shower.
Oh, right. Okay. 4. Yeah. Sweet.
I guess bath shower is when, well, that's the bath shower thing. Like you get both into it. You get the shower head inside as well.
Yeah.
Photoshop. Okay. So we had a floor whisker here. Connect the shower to that basin. Shower basin, bath basin, and you never connect the WC to that. Always have this on line. So now I'm gonna connect those two here. WC directly here. Floor whisker here. Then I'm gonna take this WC, bring it here. This one connect to this one. Floor whisker here, and this one directly here. You don't need floor whisker there because there's just one fixture. So, and what do you need a floor whisker in each room and one, not just one? Well, I think you do that to minimize the number of pipes that's going to that drain, and usually you put it in every room where there's like bathroom stuff. The one where there's only just one is usually the overflow relief gully, and this is outside the house. So like yeah, you put the overflow relief gully here, where there's the laundry. And wait, you need to connect this to here as well. And then when you've done that, you need to add the vents. So usually you put one vent at the end of the drain that you have. So like this one, the end will be here. So I put one here. That's gonna be the main drain. And if you looked at the table, what is it? Size of unvented branch drain. No, that's not this. This one. Size of rating of vents. So just to be sure, for the main one, you always take 65. That can take 30 to 175 fixtures. So this one's going to be 65. Okay, I'll finish the vent thing and then I'm gonna go back to the stormwater. Okay, do one here, and usually you put you need to have vents for the WC, but because this one is like that's 15 meters, half is 10.5, so because this is less than 10 meters, those one here can use that vent, but because this one's far away, so you need to add one vent here. So one vent here is going to be 50. And
I think Joseph's asking, floorway scully is when two or more pipes come together, like shower, bath, basin.
yeah, it's just so you don't have like many pipes going to that, because like if you had 3, you'll have 1, 2, 3. On this one, you just have 1 that's going there. I think it just makes it easier for the plumber to make all those connections. So I put a vent here, and I think I'll add a vent here as well. Because this toilet here can use this vent, but because this one it's too far from the other 2, so you just add 1 more. You okay with that, Ben? Or what do you think?
Yeah, that's good. You can put a overflow relief gully in the kitchen if you want to. You can put that outside the house.
What you mean
Heaps
here?
of ways you can do it, eh? Yeah. So you can put one on the kitchen and one on the laundry. So you've got one on the laundry at the moment. Another way to do that would be put one outside the kitchen and.
So it would be around here. Oh, you want me to put it?
Yeah, pretty much. Yeah, you can do it like that. There's heaps of ways you can do it, but yeah, looks good. That's the only place you need them for overflow relief gullies is the laundry and the kitchen. That's it. You don't need them for the bathrooms.
Yeah, because that's where usually you would have most chance of blocking because of the fluid and the detergent, stuff like that. Okay, let's go back, and don't forget, you know, when you have the fixtures gonna have like 44, 45, and then those ones gonna have 47 or whatever. Just add them all together. Like if here at the end you get 10, this one's gonna be maybe 12. So when it arrives here, it's gonna be 22. And if this one is 5, it's gonna be 27 on here. For the figure of the vent, let's go back to the table here. So that's what I use, 40, 50, 65. You always need to have like a main vent, and usually you put that at the end of the drain. So here. And to be sure that it covers all the fixtures, you use this one, 30 to 175. Usually for most residential, you wouldn't go more than that. And for the toilet and stuff, you just use 50. so it can cover from 10 to 30. Because if you look at the lectures, like on this one, I got 61 diameter for main drain because it's like at the end. And well, here I got 40 because it only has 3. If you look at the table, if it's between 1 and 10, you can use 40. But then, like for this one, it's only 7, but he decided to go with 50. But still okay. They're both good. If you make it bigger, it's safer. It just costs more money. But for the exam, you don't really care. You just, to be safe, you put 50 for the small one, 65 for the main one, and use 50 for the other ones.
Do you need a vent in the laundry?
I think you don't need it if it's close, if it's between within the 10 meters. So like this one would
10
use,
meters between each vent. Yep.
yeah. So like this one would use that vent here, and yeah. So that's why I put one here, because it was further away from that one.
Yep.
Okay. You don't need a vent on the laundry line. Well, I put it there because it was at the end of the main drain. Let's get a question. Okay, I'm gonna go back to the stormwater. Wait it. Okay, so what was the question? Can you explain why you had divided 8,000 by 100? Just like in the lecture, in his example, he was saying that you assume that the cross section of the gutter is 100. That's what we got. Gutter size required for roof in our case was 8,000. And suggested gutter size. Assume one section is 100 millimeters, then 8,000 divided by 100 will be equal to 80. Then you get 100 times 80.
I think you've answered that question. I think Sama had a question. It was how come you got the 8,000? Shouldn't it be 5,000?
No. Okay. So if you go back to this line here. So the highest catchment that we had was 59, so close to 60. So it's around that line. So you trace it. You're right here. That's the 27-degree pitch line. And then as you go down, you're up here. So that's 5,000. 6, 7, 8,000. Yeah, that's how I got that number. Good. Wait. Like you went half on each roof and counted it as one on their 2 separate roofs. Yeah, I did 2 roofs here because the water that's falling on that roof is going all the way to that gutter here. So by knowing that that's the biggest catchment that the gutter needs to have, so that's why you size it for just this one. Because if you get 100 by 80, you know you can catch this water. So that size is going to be enough to catch the 51 as well. So that's why you don't need to calculate another one for that. Because the gutter size that we've chosen will serve all of them. good. I don't know if it answers your question. Okay, well, I guess that's it, huh? Any more question?
Could you just quickly go through part C, like the structural advantages?
Let's go. Open. Oh, I should just use that one. So this one?
Yep.
What are two structural design advantage of timber as discussed in the lecture? Yeah. Do you guys have any ideas? Ben, any idea? I think for me it would be like
What's the question?
structural
Part C, yeah.
Okay.
Advantages of timber.
I'm just checking what I put on my notes. Wait a second. For me, what I wrote, that's my answers. Huh? I mean, for that you usually need to read the lectures. So I don't know if it's going to be correct, huh? Just to let you know. Huh? I said like natural elegance. Wood has more charm, I guess, from the concrete and the steel. Like the detailing with the joint, the junction. Yeah, it can be more complex detail. And the shape they get. Wait. Just going through his lecture. I think that's number 3. Of course, this one is not inside.
Yeah, timber has similar tensile and compressive strengths. That's what Pre's saying.
So you said more tensile compressive.
Yeah.
Long lasting, durable, readily available, good tension. Well, thank you, Eva. That's what she wrote. Yeah. I think there was other things you can just timber. It's common use, like people know how to work with it. It's cheap. And it's available. Yeah. It's in lecture 3. Okay. So after the advantage of steel, I guess like the span to weight ratio, it's high, so it can have long span. It's sustainable, I guess. You can reuse the steel after. Can be prefabricated, fast construction. If you have anything else, just add it in the group chat. But yeah, it's all in the lecture.
Yep.
Structural design advantage of concrete. I think it's like a strong compression resistance or something. Durability. And low maintenance. Yeah, I think lightweight is correct for the structural advantage for the steel, I guess. Yeah. So it would be like the weight, the span. And didn't he say something about like you can walk or something, like some type of bridge you can walk in between? Yeah, here. Well, didn't he say something about this in the lecture?
Is that for the steel?
Yeah. Live load. What is live load? For me, it's like the weight of all the things that have been added to the building, so people can do their work. Or what's the definition behind it? Live load is the load assumed or known to result from the occupancy or use of the building. For example, will be the desk, the people, the books, the signs, the plants, stuff like this. So all the things that bring after the building is finished. Like the dead load will be the structure, the
Yep.
wall, the floor, the ceiling. I guess will be like live load will be all the furnitures, the fit that can be removed and wouldn't affect the structure or the stability of the building.
Yep.
What is the significance regarding the structural loading of the handrail? Transfer below. So this one, I think it was like you should always size your handrail for more than it's required, because you never know who's gonna sit on it or how many people is gonna sit on it. Okay, and for this one, that's a bit weird. But in the lecture, he was saying that where is it? I think it's lecture 2 or 4. Let's check. That's not here. That's not here as well. Oh god.
Was this for question F?
Yeah. Here. Process versus project, and I think the answer would be working in plan, and then working in section. Yeah. So if you want to know a bit more, just read those slides. Lecture 1, slide 32 and 33. Okay, well that's it, huh? Any last question before we go back to bed? Oh, do quick, huh?
Oh, yeah. Okay, good luck, guys.
Okay. Bye bye, everyone. Thanks, Ben.
Cheers, Steve.